Module 1, Lesson 6, Algorithms in Data Science. So in this lesson, we are going to consider the algorithms that are used in data science. It is good that you have a general understanding of all these algorithms so that you might know how to apply them and how to choose them when you are engaged in a data science project. So generally, at a upper level, these algorithms are divided into supervised and unsupervised algorithms. We are going to look at the definition of supervised and unsupervised algorithm, so do not be worried. But now, it is good to understand that under the supervised algorithms, we have the regression algorithms, the decision tree algorithm, the random forest algorithm, and the classification algorithm. And under the regression algorithm, we have the linear regression and the multiple regression. Now, under the classification algorithm, we have the KNN, the logistic regression, the SVM, and the naive Bayes. And under the unsupervised algorithms, we have the clustering algorithms. That is the K-means algorithm and the PCA algorithm. We have also association analysis and the hidden Markov model. And so, the regression algorithms, the decision tree, and the random forest, together with the clustering algorithm in the unsupervised algorithm, they are used on continuous data. That is, data such as temperature, height, distance, etc. While the classification algorithm under the supervised algorithm and the association analysis under the unsupervised algorithm, together with the hidden Markov model, they are used on categorical data. By categorical data, I mean data which is not continuous. Let us say, for example, you are defining whether an animal is a mammal or a reptile. That is what we call categorical data. It is not continuous data. Basically, these are the main algorithms that are used in data science and machine learning. So let us define what is supervised algorithms. So in supervised algorithms, the computer is presented with an example input and their desired output. The goal here is to teach the computer a general rule that defines the input to the output. Thus the name supervised learning. In this case, you are supervising the learning process of this algorithm. That is, you have an input and then you have a desired output, but you don't know the general formula that maps the input to the output. You want to find this general formula such that when in future you have an input but you desire an output, you can then just present your input to this algorithm and it will generate an output. So what you're looking for is this general rule that maps the input to the output. So let us look at supervised algorithm. Here, you do not have any historical data from where the computer can learn. Let us say maybe you're working on a totally new research with no historical data that defines the input and the output. Here, the computer generally uses an underlying complex algorithm to create inputs and outputs and a formula of how to map the inputs to the outputs. The computer nearly does everything for you and you are not generally supervising as in supervised algorithm. So let us look at the regression algorithm. Here, the regression algorithm, they are basically used to define the relationship between dependent and independent variable. 2, they are used to predict the dependent variable based on the relationship defined. So suppose you're working for a company and this company have a website and this website brings revenue depending on the traffic. And so this here is an example of a regression algorithm. Why? Because we have a dependent variable which is revenue, which depends on the website traffic. And so when this is plotted into a graph, this is what is called a regression algorithm. The dependent variable in this case will go to the y side or the y-axis and the independent variable will go to the x-axis. And so you can predict the dependent variable based on the independent variable. In this case, for example, you can say when the website traffic increases up to 4.5, then our revenue can be around 13,000. So generally, that is what is called regression, predicting the dependent variable based on the independent variable. And this is usually plotted on a graph in terms of y and x. We will look it further so that we can understand while doing our project. Let us look at the decision tree. So in decision tree algorithm is basically used to solve problems by defining a series of questions in the rank of their importance and their specificity. This is what I mean. Suppose you want to buy a furniture online. What you'll do, number one, is that you'll go and look at the website whether it is selling furniture or not. And if it is not selling the furniture, you will close the website. And now you can go further to this website that are selling furniture and look at their ratings. If their ratings is greater than 4, then again you can proceed and close all other websites whose rating is less than 4. And now in this website whose rating is greater than 4, you can consider if they are giving a discount of greater than 20. If they are giving a discount of greater than 20, then you can go and purchase your product. If not, then you will not purchase your product from this website. That is basically what is a decision tree. You define a series of questions based on their specificity from general to more specific question in order to achieve or solve the problem which you have at hand. Let us look at another example. Suppose you are a shopkeeper and you have a bunch of fruits and vegetables, but you don't know how to categorize them. So you might apply the decision tree algorithm in categorizing this. For example, you might start here. Is it colored orange? No. Then broccoli will come here. Then on this other side you have oranges and carrots. Is it round? No. If it is no, it means it is a carrot. If it is yes, it means it is an orange. Let us look now at the random forest algorithm. So a random forest is simply a combination of decision tree. You are applying more than one decision tree in order to come with a more viable, dependable, more solid solution on your problem. Suppose now we have a person named Sam who is joining a new school. But Sam is not sure which course to take. Therefore, he applies the random tree algorithm unknowingly to reach a more viable decision by asking two of his friends. The first one is Jen. Jen asks a couple of questions in a decision tree format and reaches a conclusion that Sam ought to take the math course. So here is Sam. He goes to Jen. And Jen asks questions like, do you like theoretical or practical stuff? Then Sam answers, I like practical stuff. And Jen says, oh, so you like practical stuffs. On practical stuffs, do you like maths or science? And then Sam says, I like maths. And so based on this question, Jen suggests that Sam should take math. But now Sam is not satisfied. So he goes ahead and asks Terry the same question. Terry, also based on a decision tree algorithm, asks Sam some question and arrive at the conclusion that Sam ought to take mathematics. So he goes to Terry, and Terry now asks questions like, do you like calculation? Sam says yes. And then he asks, do you like statistics? Sam says yes. And then he goes now, based on these two questions, he concludes that Sam ought to take mathematics. Now, this is simply how the random forest works. It usually combines more than one decision tree in order to increase the accuracy of the algorithm being chosen. In this case, now Sam will be more confident that he is inclined to choose mathematics as compared to other classes. So this is how basically random tree forest works. So let us look at clustering algorithm. And so in clustering algorithm, what you basically do is that you are dividing objects into clusters which are similar between them and dissimilar to the objects belonging to other classes. And here is a good example so that you might be able to understand. So assuming you have 20 places to visit in 4 days, but you do not have any idea where to start from. So you go to your friends and you apply clustering without even knowing. You go and ask them this question. I have 20 places to visit in 4 days. How can I be able to do this? Your first friend says, consider using clustering. And the second friend says, divide the places into 4 clusters, then visit each place in one cluster in 1 day. You could use distance to cluster these places. In this case, you have 20 places, so you could divide them into 4 clusters, each cluster with 5 places, and these places you are considering the distance between them. So in the first day, you'll be visiting these 5 places, the second day the next 5 places, and in the third day the next 5 places, and lastly the last day those 5 places. And so that is what basically clustering applies. So in real world, it is used in customer segmentation to categorize customers who like preference of certain goods, or who love certain product, or who are certain age. It is also used in social network analysis to categorize, let us say, a bunch of people who love certain functionality in social media, or who prefer certain news, etc. It also used in city planning. In city planning, it is used to categorize areas whereby it is favorable, let us say, for certain industry, and to categorize areas which is not favorable for certain industries. Now let us look generally at classification algorithm. So classification algorithms, they are used to classifying objects into categories. So, and I have an example here which is basically so easy to understand. What do? You have an object, but you don't know how to classify it. So for example, you have cats and dogs, but now cats, they have sharp claws which they use to climb, they have smaller length of ears, they mew, doesn't love to play around. But dogs, they have dull claws, bigger length of ears, barks, they love to run around. So based on these features, when you see an animal which has sharp claws, smaller length of ears, and it doesn't love to play around, you can then say that this is a cat. But if you see an animal which is dull claws, bigger length of ear, barks, and love to play around, you can then conclude that this is a dog. So generally, this will happen when the algorithm will be classifying this item. It can classify items either as cats, as dog, based on this feature. Now, these are the basic algorithm which are required to understand in order to work in a data science project. So you are now good and ready to proceed to our next module, where we'll be understanding how to work with the Python programming language.